Okay. All right. So again, if anybody has any questions that they want me to do specifically, either from the review sheet or if they just have like a type of question they want me to go over, feel free to yell it out or type it up and I will start there. Otherwise, I put together a few things, but I'll let you guys go first. So anybody out there with a request?
Would you be able to go over some more word problems?
Anything specific about word problems?
Just more problems in the word format, I guess. We didn't do too many of them in class or on the review or homework, so I just wanted to see some more.
Okay. All right. So I had put a couple of things together here. And so let me just kind of pull that up. And sorry, just making sure that I'm recording still. Okay. So when it comes to word problems, the truth is, anything that has to do with some kind of ratio where there's a top number and a bottom number, that's really what a rational function can be useful for. So when we did the couple in class, we mostly did ones that were talking about average cost. Oh, hold on. I don't think I shared my screen, which that's not helpful. All right, let me try that again. Okay. Oops. Okay, so just to check first, can you guys see my class notebook?
Yeah.
All right. Thank you. Okay, so when it comes to word problems, and again, keep in mind, you're right that we didn't do too many of those. So I would assume that you wouldn't see more than one of them tomorrow, if that, because I certainly want the test to be representative of what we went over. So when it comes to word problems, the most common one that has to do with rational functions really is about the average cost. And when you're talking about the average cost, you have to first understand how to find the total cost. And the truth is, if you understand the total cost part of it, again, I can ask you any type of word problem that has to do with a ratio. So the total cost is usually a y equals mx plus b. Doesn't have to be, but a lot of the time it is. And when it comes to the bottom number, if you're trying to take an average, you always divide by the number of items that you're producing. And if you don't know what it is, you call it X. So there's a little example here. You are trying to model the average cost for making light bulbs using a rational function. So again, on the top, this is some version of y equals mx plus b. You're assuming that if you own a light bulb factory, you have to pay some fixed cost to run your plant, and then you have to pay a specific amount per light bulb. So again, that's usually your top number when it comes to average cost, and then your bottom number is how many items you're making, and if you don't know what that is, you call that X. So that's the most common iteration of word problem about average cost. But the truth is, anything where you can create a ratio, that is something where it might come into play. So I can't show you one of every single type of problem that exists. We did a bunch of average cost ones, so I kind of picked some other ones here from the internet. So if you look at the first one here, it says Anne and Maria play tennis every weekend. So far, Anne has won 12 out of 20 matches. How many matches will Anne have to win in a row to improve her winning percentage to 75%? So again, even just at first read, it might not seem like something that is automatically going to be a rational function. So let's talk about why it is. So I'm going to call this M of X just for matches. And again, if I don't specify what the variable has to be, you can pick. If we're talking about the fact that right now Anne has won 12 out of 20 matches, you would assume that that's 12 out of 20. So that's just a regular ratio, no variables. But if you add some variables to it, you can see why it is a rational function. So how many matches will she have to win in a row to improve her winning percentage to 75%? So basically, she has won 12 out of 20 matches. That is her initial winning percentage, the y-intercept, as it were. And now you're trying to figure out how many more matches will she have to win in a row. Well, if you don't know the number of matches, you usually call that a variable. In this case, let's call that X. We know that she has to win that many matches, but she also has to play that many matches. So we're going to add an X to the top and we're going to add an X to the bottom. Now, keep in mind, if you were to graph this, you would be able to find all the same attributes that we've been doing the whole time. You could find the zero and the y-intercept and the vertical asymptotes and the horizontal asymptote. You would just have to think about whether or not that makes sense in the context of the problem. But hopefully it makes sense why this is the equation. Again, the initial ratio, 12 out of 20. You're trying to win some mystery number of matches, so you have to win them on the top. and you also have to play them on the bottom because you can't have one without the other. If that is the rational function that you are dealing with and you want your winning percentage to be 75%, well, then that means that you're going to take this equation, so 12 plus x over 20 plus x, and you're going to set it equal to 75%. Anybody can tell me what might be the best way to write 75%? That's the easiest to work with. If you didn't have a calculator, since you won't tomorrow. Instead of 0.75, another way that I could say 75%.
3/4.
3/4, okay. Or you could say 75 over 100. That might make more sense, at least for the start. And then certainly reducing is going to make your life easier. And then we did see some questions like this. If you were now trying to solve for x, what would you do? Anyone? Okay, cross multiply. So if you were to cross multiply, you would get 48 plus 4x equals 60 plus 3x. Put all the x's on one side, put all the numbers on the other. Turns out that she would have to win the next 12 matches in a row in order for her winning percentage to increase to 75%. So again, we didn't do any problems in class that were like this type of problem, but the idea of setting up a ratio, that is really the whole goal of all the problems that you've done so far. So even if you see a context tomorrow that you're not 100% sure with, as long as you can understand the ratio behind it, that's really kind of what I'm going for. So again, if you want to just kind of think about that in like a different way, just a random way, like let's say I'm talking about the ratios of boys to girls in the class, boys to girls, in a movie, whatever you want to say. Let's just call this function f. Let's say that we start off with a ratio of 10 boys to 15 girls. Again, that would be the initial ratio, the y-intercept as it were. Let's say that the number of, so again, this is the boys to girls. Let's say that every year the number of boys is increasing by 6. You would say plus 6x. So if x was a year, let's say that every year the number of girls is increasing by 5. You could say plus 5x. And then again, once you have some ratio, that's a rational function. It follows all the rules of rational functions once you go ahead and graph it. So anybody with a question on this example? Again, I can't tell you what the word problems tomorrow might be in reference to. I also can't show you one of every single kind. But what I'm trying to impress upon you is this idea of creating a ratio. And if you create a ratio, a top and a bottom, a numerator and a denominator, that is what turns it into a rational function. And it follows all the graphing rules of rational functions. You just have to look at it with a real world lens. I have just some words here that you're trying to convert to an equation. So 7 divided by the sum of a number and 2 is equal to half the difference of the number and 3. Find all such numbers. So again, we didn't necessarily do any problem that was just like this. The idea behind this is, again, you're trying to come up with some kind of a ratio. So let's let x be the mystery number. If I go ahead and try to convert the yellow, I would say that 7 divided by the sum of a number and 2. So that would be 7 plus 2. Then let's say that it has to be equal to half the difference of the number and 3. So the difference of the number and 3 would be x minus 3. To take half of that would be 2. Again, if you had some kind of a word problem that involved this, you would now want to put them on the same side. So you'd want to have 7 over x plus 2 minus x minus 3 over 2. You would set this equal to something depending on what the problem was asking you for, or it could just ask you to find some equation. And then you would find a common denominator, which would be the 2 and the x plus 2. And then you would go from there. So, Sarah, I understand your question just in terms of, you're right, we didn't do a ton of word problems. But again, if you understand this idea of average cost, and if you just understand the general idea of making a ratio, I think that that's probably going to be good for tomorrow. But if anybody would like to ask me any specific questions about either these or about anything, I'm happy to entertain those. So anybody with other questions about word problems? Okay, let me check the chat, make sure I'm not missing anything. Okay, at the moment, I don't see any other questions that people have. So does anybody have any questions about anything that they'd like me to go over? Okay, let me show you then a couple more things that I put together and maybe it will trigger something. So again, take a look at the top here. So I have this function x over x squared minus 9. Of course, you can factor that as x over x plus 3, x minus 3. At this point, these functions can get really, really difficult, really, really funky, really, really fractiony. That is not my goal for this test. My test is to test you on the rules. Do you know the rules frontwards and backwards, upside down and sideways? Do you know how to find the zeros? Do you know how to find the y-intercept, the horizontal asymptote? And can you explain it? So that's really what the focus of my test is. Can you apply the rules and not so much, the special cases? Not every problem on a test can be a special case, since that wouldn't be fair. You guys at this point honestly seem to be pretty good at graphing. So just to kind of remind you of a couple of things. So if this was my function in question, my 0 would be 0. That would be the x-intercept and the y-intercept. You would have one vertical asymptote from the x plus 3 at negative 3. You would have a second vertical asymptote at positive 3. Because of the fact that there are two vertical asymptotes, remember, every time you have a vertical asymptote, it cuts the graph into an additional piece. So that's how you would know that there need to be 3 of them. In order to figure out where the pieces go, you'd probably want to start with the piece in the middle. For the piece in the middle, you would have to figure out, does it go from the top to the bottom or vice versa? And for that, you might have to test some point. Again, you could test something like 1 or 2. You could test something like -1 or -2. Once you found out that this point here, let's say, has to be the green, you know that the middle piece has to look the way that it does, because it would have to go through the x-intercept and then travel down along the other vertical asymptote. Remember, horizontal asymptotes really only apply at the ends. So the fact that you crossed one in the middle is allowed as long as the values are small. In order to find the 2 remaining pieces, you could either test some additional points if you want to, or remember the rule, because of the fact that each of these vertical asymptotes is only to the first power, which is an odd value. If this piece of the graph goes up, I know that this piece of the graph has to go down. And if this piece of the graph goes down, I know that this piece of the graph goes up. They always have to have opposite behavior as long as you have only a first power. So any questions on that? Again, the truth is you guys really were getting pretty good at these the more we did of them. So maybe you're just here because, maybe you're here because I said I wanted more people to show up. But again, if you have questions, please don't be shy. Here for the second one, okay, again, I'm just trying to, reiterate all the different things that can happen. So this is partially factored. In order to factor completely, you'd have to factor the numerator as the difference of squares. And that is how you would get your 2 zeros. Then, of course, you would have a vertical asymptote here at -2. You would have a vertical asymptote here at +3. Because of the fact that there were 2 vertical asymptotes, again, you know that there have to be 3 pieces to the graph. Even though it's not technically drawn, where is the horizontal asymptote for this problem? Anyone can tell me? If you look at the equation.
At 1.
It's at 1, okay. And the reason why it's at 1 is because of the fact that it has the same degree. So you would have an x squared over a 1x squared, and you would do 1 over 1, which of course would give you a 1. Notice that in this case, you do not cross the horizontal asymptote, because in the middle, you have these 2 x-intercepts, whatever this y-intercept is. There is no need to cross the horizontal asymptote, which is perfectly fine. Again, as long as you're following it off to the infinities, that's really our main priority. This is just another example here, again, for that little trick if it helps you. Notice in the first one, this x, okay? The fact that this is x to the first power, which is an odd number, means that if part of the graph to the left of the asymptote goes down, the piece to the right has to go up. They have to go in opposite directions, where over here, because of the squared, means that they both have to face up or they both have to face down. So remember, this is just meant to be a little trick as a time saver. It's meant to reduce the number of points that you actually have to test. But if you're so confident with just testing, then you can feel free to do that. But again, just a time saver. Just another little piece here to remind you that, again, it is okay to cross horizontal asymptotes as long as they happen in the middle. And then again, to find this piece and this piece, you would either have to do the opposite behavior of what's happening here and here, or you would have to test some values. Here for the next one, the end behavior is the slant asymptote. So one value on the right is getting higher and higher and higher. The value on the left is getting lower and lower and lower. They show you here what the slant asymptote is, but let's say that you want to find it yourself. So if you want to find the equation of the slant asymptote, remember, of course, you're going to do so using long division. I know that long division isn't everybody's favorite, but it should never be more than 2 rounds. It should always be relatively short and sweet. So if I go ahead and perform this long division, remember you're always doing first into first. So you're trying to say 2x times what gives you x squared. And again, there's another little trick here. If you're ever doing this for fractional values, the value that goes up top is always going to be this ratio. So you know that it has to be 1/2. And you know that it has to be x because, again, a slant asymptote always has to be linear. So if you're having any fraction problems, you can always just double check that ratio. Once you have that 1/2 x, multiply it by the 2x. That's how you get x squared. Multiply it times the 2. That's how you get plus x. Then remember what I always say, draw the line, change the signs. The squareds are gone. You have negative 2x plus 4. Again, first into first. So 2x times what is negative 2x? That's going to give you a -1. And again, you don't even have to finish it if you don't want to because you disregard the remainder. This y equals, that is going to be your slant asymptote. So be sure that you start at the y-intercept and then perform the appropriate slope. Another note here about this problem. So when it comes to this problem, on the bottom, you can factor out a 2. That's going to give you an x plus 1. That's how you know that the vertical asymptote is at -1. For this numerator is not factorable. If you get a quadratic that is not factorable, you would have to use the quadratic formula. And here's the thing, by looking at this graph, the fact that it doesn't appear to have any zeros means that these turn out to be imaginary. Now, again, we haven't seen too many that are like that, although when we have, we tended to call them none. But it's perfectly fine if there are no real x-intercepts. So, don't be shocked or confused if that happens. And again, it can happen either if you're just left with a constant on top. This would be an example of something that's a none because 2 will never be 0. Here would be another example where you'd have no zeros, and that is when they are imaginary. Any questions on any of that? Again, I am more than happy to go over specific questions or specific concepts that anybody has in mind. I just haven't heard any questions, so I'm just, giving some. Here's another example, which again, let's say anybody out there was looking to do a practice long division. Here would be one that you could write down and do later, and the answer should be 3x plus 1. You have the equation here, so you can factor and solve the top. You could plot all the different points. And again, for a graph like this, when you have them as parabola shapes, just don't forget about this second piece. Again, there is one vertical asymptote in this problem, so you know that the graph has to have 2 pieces, and sometimes people forget about that little hidden one up there, so try not to do that. The 2 general shapes involving slant asymptotes are this one with the 2 parabola shapes, and then this one where they're kind of They just look a little bit longer. They're not quite as parabola-y. But these are kind of the two general shapes that you should always get when slant asymptotes are involved. Again, I just picked another weird one here, excuse me, to show you again some of the special things that can happen. So notice over here on the very left side, the reason why this graph has to live where it does is because it cannot be here because there are no x-intercepts. So you can't have any fake x-intercepts. As far as the piece in the middle goes, the y-intercept must be negative and there must not be any zeros there. So that's how you know that the graph has to face all the way down. For the piece over on the right, because of whatever the equation has to be, which again, I don't actually have it, but basically it appears that it crosses the horizontal asymptote, which again, you'll only do that if the algebra and the points tell you to do so, but it's perfectly fine to do so as long as you are following the horizontal asymptote at the very ends. Again, another word for horizontal asymptote is end behavior, so make sure you focus on the end. And again, this piece faces up and this piece faces down. This piece faces down where this piece faces up. So that must mean that whatever is in my denominator must only be to the first power. Otherwise, they would go in the same direction. I really do think that most of you were showing a good understanding of the rules. So the only other thing I can think of that you might want to practice is just you want to make sure that you can do your factoring. I think I said it in all the periods, but just a case again, you are not going to really be pressed for time on this. I think you should have more than enough to do every problem and even check your work. So please make sure that you, do so. So just to kind of go over a few different kinds of factoring, let's say you had x squared minus 4. That is, of course, the difference of squares, x plus 2 and x minus 2. Be careful, though, because if you had x squared plus 4, you cannot factor that. These turn out to be imaginary. So again, while it is wrong to not factor, it's also wrong to factor when you're not allowed. Don't be surprised or don't, ever be surprised if you see something that's a slightly harder version of the difference of squares. Instead of having a perfect square just in the back, you also have one in the front, but the same rule applies. Square root of the front in the front, which would be 2x. Square root of the back in the back, which would be 5. And then, of course, you need to have one that's positive and one that's negative. Might seem like the easiest type of factoring is the greatest common factors, but believe it or not, those are usually the ones I saw people mixing up the most. So make sure you know the difference between 5x squared minus 50 and 5x squared minus 50x, because if you have an extra x or you lose an x, you're going to get way different answers. So here for the first one, you can only factor out the 5, which gives you x squared minus 10. Here you can factor out a 5x, which gives you x minus 10. And again, whether you have an x on the outside versus just a 5, that's a big difference in terms of where the zeros are. What you're left with, this is going to give you x equals 10. This is going to give you x equals plus or minus radical 10. So again, very, very different. Let me just write those down. Again, if you were to set each of these equal to 0 and solve, this is going to give you an answer of plus or minus radical 10, where this is going to give you an answer of 0 and 10. So again, very, very, very different. Any questions on those? Most of what we've been seeing are simple trinomials. So x squared plus 8x minus 20. You need factors of the back that add to be the middle. So factors of 20 that make an 8. I think we're going to try 10 and 2, and it would be plus and minus. And again, if you happen to mix up these signs tomorrow on the test, your whole graph is going to be wrong. I mean, you're going to get partial credit, of course, but things are not going to be, all the problems we've done so far, all the points have kind of, joined beautifully to make the graph. So if you have things going haywire tomorrow, it's probably because of the fact that you mixed up a sign. And then for tomorrow, really the hardest that you have to be able to do for factoring would be something like 3x squared minus 7x minus 20. So this would, of course, involve the AC method or whatever method you've been utilizing. The AC method, of course, means multiply the first and the last, which would be negative 60. You would then need two numbers that multiply to be negative 60 and add up to be negative 7. So 1 and 60, that doesn't work. 2 and 30, 3 and 20, 4 and 15, 6 and 10. Looks like I would need 12 and 5. So I need 12 and I need 5. And if they're going to add up to be a negative 7, it needs to be negative positive. So 3x squared minus 12x plus 5x minus 20. I'm going to group the first two, and then I'm going to group the second two. So if I take out a 3x, I get x minus 4. If I take out a 5, I also get x minus 4. This is a really good sign. The fact that I got a repeat, that means that that's half my answer. And then here is my other half of the answer. So again, factoring is paramount, but you guys really have been doing pretty well with that. So, my expectations are pretty good. I guess all I would say otherwise is because there is no calculator, I have made all the numbers relatively nice. But again, you should be able to do simple calculations without it. So like if I said to you negative 20 divided by 4, and let's say you're trying to find a y-intercept, you should of course know that that would reduce to be negative 5. Whereas if it was negative 4 over 20, you should of course know that this is negative 1/5. So you just want to try to be careful not to make those little mistakes because you don't have a calculator. And again, you should know that 1/5 is 0.2. You should know that 3/2 is 1.5. You should know anything divided by 2, things divided by 5, things divided by 4. Again, I really worked hard to make sure there wasn't anything, crazy. So let me just go back here to the meeting, just kind of see who came. Okay, looks like there's a few more people than usual. So I don't know if that was because you want to set up yourself for success here, or if just because I said I wanted more people. But I hope that it's helpful. Can I do anything else for you guys? Any specific questions, or just any general questions that I can answer for you? I mean, I'm happy to keep going if there's anything else you guys want, but if there's not anything else, I'm not really sure what to do. So anybody have anything? Just to check, you guys are still there? Okay, yeah, sounds like someone's there, I guess. All right. So the test tomorrow, again, it's worth 50 points, 50. It's no calculator for the whole thing. It is 6 multiple choice questions. It's 11 total questions, although, again, sometimes the number of questions doesn't matter since some of them can be really short and some of them can be a little bit longer. I do think you'll have more than enough time, so take your time, read the multiple choice questions carefully. Make sure you only choose one solution for each, since that's all there is. And then again, if the pieces of your graph don't wind up working together, I would say probably you just did a simple error with your factoring or your calculations, and you should go back and check it. So again, if anybody out there has a question of any kind on anything, please say it now or please type it in the chat. Otherwise, if there's nothing else, I feel like we might be done. So I'll stay here until I'm the last one. But otherwise, again, if you have anything else, let me know. But, I don't think you have to study all that much. I do think you guys have been preparing along the way. But again, I'll stay until I'm the last one.
Thank you again.
All right, you got it. Thanks, guys.
Thank you.
Have a good night.
Thank you.
Thanks, guys.
Thank
All right, good luck, guys. See you tomorrow. Thank you.